This is one of a series of videos produced by the Further Mathematics Support Programme for A-Level Mathematics Revision. In this video I'm looking at the AQA Decision 2 specification, and this is question 4 from the June 2011 paper. As soon as you see the question, you realise that this is going to be a simplex question, and indeed we're told that the table is simplex tableau, and we're asked to write down 3 inequalities which this table represents, other than the non-negativity ones. It then says choosing y as the first pivot column, we have to use one iteration of the simplex method, and then to interpret that as if an optimum value had not been reached, so we have to find the possible values of k. Then says in the case when k is actually equal to a particular value 20, do one further iteration and interpret the final tableau. Okay, so the first part of the question is just asking us for the inequalities. So if we look at those, we're just reading off the second, third and fourth rows here. So in the first row, 5x plus 3y plus 10z, and then that must be less than or equal to 15. So we're not including the slack variable in there, we're not including the s, it's the inequalities that we want, so it's less than or equal to 15. The next one is 7x plus 6y plus 4z is less than or equal to 28. And finally then 4x plus 3y plus 6z is less than or equal to 12. 2 marks allocated for that, a method mark and an A mark, simply for getting something or all correct. The next part of the question asks us to do one iteration of the simplex method, starting with column y as our pivot. The reason for the column y is we've got the -6 in there, so it's perhaps the most negative value. But we're using column y, so what we have to do is to work out what are called the theta values by taking the value in each row divided by the number in that column. So 15 divided by 3 is equal to 5. 28 divided by 6 is equal to 4.5. And then finally 12 divided by 3 is equal to 4. And we want the smallest positive value, so that's equal to 4, and that gives us then the pivot here as 3. Now what we have to do now is to arrange for that row to become, or so that column, I beg your pardon, to be 0, 0, 0, 1. So the first thing to do is to work out that we can do row 4, let's call these row 1, row 2, row 3 and row 4, and we can make that a 1 by doing row 4 divided by 3. So you end up with, in that row, 4/3, 1, 2, 0, 0, 1/3 and 4. The other rows we can do by adding multiples of row 4 to each of row 1, row 2 and row 3. So if we look at row 1 first of all, it's -6, so we'd have to take row 1 plus 2 lots of row 4, and that will produce a 0 in that. Now if we do that, we get 1, and then -2 plus 8 gives us 6. The 0 there is designed. The next one, -k plus 2 lots of 6, so that's 12 minus k. then it's 0, 0. In the U column we have 0 plus 2 times 1, so that's 2, and finally 0 plus 2 times 12 is 24. To get to the next row, we're going to have to just subtract, so this will be row 2 minus row 4, and that becomes 0. 5 minus 4 is 1. The 0 in the next column. 10 minus 6 is 4, and then 1, 0, negative 1, and finally at the end 15 take away 12 gives me 3. And finally row 3 minus 2 lots of row 4. So that becomes 0, 7 minus 8 is negative 1, 0, then 4 minus 2 lots of 6, so 4 minus 12 is negative 8, 0, 1, 0 minus 2, so negative 2, and then 28 minus 2 lots of 12 gives me 4. And there's our final tableau after one iteration. We're told we're asked to find the value of k, assuming this is not optimal. So if it's not optimal, then we need a negative value in the top row. So we need 12 minus k must be less than 0, and therefore k is greater than 12. Well, that's it for part B of the question. Let's look at the marking of that. There was a method mark for actually obtaining the row reductions here, the row reductions, the row operations, and 2 A marks depending on how many of those you got correct. There's actually before that a B1 mark, just an allocated mark for working out that the pivot was 3. So that was the 4 marks for the simplex iteration, and then a method and an A mark for finding that k was greater than 12. Well, the question goes on to say, in the case when k is equal to 12, so remember that we had k equal to 20 rather, 12 minus k was the value there, so that is equal to negative 8, hence this value has gone in that position there, negative 8. So this is the tableau that we're working with. We want to do one further iteration. So our pivot column is the Z column with the negative value there, and again we work out these theta values. So we want to do 3 divided by 4, so 3/4 for the first one, 4 divided by negative 8, so that's but that's less than 0, and 4 divided by 2 is equal to 2. So the smallest positive value is the 3/4, which means that the 4 there is the pivot, and the Z column is going to become 0, 1, 0, 0. So we need to do that first of all by taking row 2 this time and dividing it by 4. So this will be row 2 divided by 4. So we end up with 0, 1/4, 0, 1, 1/4, 0, negative 1/4, and 3/4. The top row we've got to make 0, so we're going to have to add 2 lots of that, so this will be row 1 plus 2 lots of row 2, so a nice easy one to do. Becomes 1, 8, 0, 0, and then 2, 0, that one becomes 0, and then 3 times 2, 6, so 24 plus 6 gives us 30. we've also got -8 in the next one down here, so again adding 2 lots of that row. So this will be row 3 plus 2 lots of row 2. So that gives us values of 0, 1, 0, 0, and then we're adding 2 lots of 1, so 2, 0, -4, and 4 plus 2 lots of 3, giving us 6. The final row, row 4, we need to subtract from that half of row 2. So we're going from 4, we're subtracting half of 4 to give us 0 there. So this is row 4 minus 1/2 of row 3. So when we get that, we get 0. Then we get 4/3 minus 1/2. Well, that's the same as 8/6 minus 3/6. So that's 5/6. A little bit of fractional work going on there. Then 1. 0 minus 1/2. 0. And then 1/3 minus negative 1/2. So that's the same as 1/3 plus 1/2. Or 2/6 plus 3/6 is 5/6 as well. And finally 4 minus 1.5 gives us 2.5 or 5/2. So there's our final iteration. We're asked then to interpret the tableau and state the values of the slack variables. So in interpreting the tableau, the first thing to say is that this is optimal because there are no negatives in that top row. So the optimal value has been reached. And we can read off then the values. P is equal to 30. X is equal to 0. That's because this X column has not got 0s and 1 in it. So X is equal to 0. Y, we can see the 1 is in the bottom row, so Y is equal to 5/2, and Z is equal to 3/4. For the slack variables, S is equal to 0, and U is equal to 0, but the T value, the 1, I've missed the 1 out there, that should be a 1, sorry, a slight mistake there, there should be a 1 in that position there, row 3, and so T is equal to I've actually made a mistake as well in that value. I think T is equal to 10. Yes, apologies, I'd written in the value that I added. It should have been 4 plus 6, which gave a value of 10. So the T value is actually equal to 10. Okay, so that's the end of the working. For the marking, 4 marks for doing the second iteration, a method mark for getting that pivot correct, and then 3 marks for the correct values in these rows that we had to calculate, so as doing the row operations. That was the 4 marks there. There were then 3 marks for the interpretation. An explanation that the optimal value had been reached. B1 mark for these, and a follow through if you'd made mistakes in the iteration. And then a B1 mark for the slack variables. That's the end of that question. You can find answers to other questions and information at www.furthermaths.org.uk.